Are you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you ready to go?
Hello, it's Mr. T, and today we have a tutorial on graphing exponential functions. We're going to first start by exploring what the graphs of exponential functions look like, and then we'll go into the procedures of how you can simply graph exponential functions using pen and paper. So we're going to start with looking here at our basic exponential model, y equals ab to the x. We've used that when we were solving exponential growth and decay applications. If you remember, the b is our growth or decay factor, and when b is bigger than 1, it's exponential growth. So we're going to start out with growth. So I've set b here to 2. And remember, a was our initial amount, and I've started out with a as 1. So let's look at the graph. Couple important things to notice on exponential graphs. One is we have a floor for the function. We have a horizontal asymptote. And for the base function here, the horizontal asymptote is the x-axis, which is the line y equals 0. As the function gets close, as x gets further to the left for exponential growth, it's getting closer and closer to this line. It's never actually touching the horizontal asymptote. It's just getting closer and closer. Also, our initial amount a, initial amount is when our exponent is 0, so that's going to be our y-intercept. So a is going to give us our y-intercept. So let's look at what happens as we change first here the size of the growth factor, meaning that we're going to be increasing at a faster rate. So as a becomes bigger, we can see, if you watch this graph here, let me just animate it, our graph is getting steeper and steeper. So the bigger the value b, the more rapidly the function increases. And as you would expect, as a changes, our initial value is going to change. So on the graph, our y-intercept is going to change. So let's look at that. Now, if you remember from other translations, when a is negative, it flips the function. So now you can see when a is negative, our function is flipped. Now, this is still referred to as exponential growth, even though, let me pause this here. So even when a is negative, this is still exponential growth, because as x gets bigger, the value of y, or its distance from the x-axis, is increasing. So sort of you could view it, the absolute value of y is getting bigger as x increases. So let's look at exponential decay. So I've got our exact same model here, but I've set b initially to 0.5, which is 1/2. So you can see the graph has the same shape, but now it approaches the horizontal asymptote on the right side of the graph as x approaches positive infinity. And it has the characteristic exponential bend, the increase, as on the negative side as x goes to the left. Now remember, this would be when we were doing exponential models, 0.5 for b would be a 50% decrease. If I increase b here, my percent decrease is left, so this would be a 20% decrease. And if I go the other direction, this would be, say, an 80% decrease. So in this case, as b gets smaller, it gets steeper, and as b gets closer to 1, it levels out. So we can animate that just to see the values of b. So now let's look at what happens if we add translations. Remember, translations, we'll be adding an h and a k variable to our template here. And if you remember from our last unit on graphing square root functions, and also on quadratics, those cause either horizontal shifts or vertical shifts. So let's look at an exponential growth with translations. So now our model inside the parentheses in our exponent, we have now x minus h and k. Now I've initially set h and k equal to 0, so we have our base function. Now if you remember from other functions, this number that's added outside of the parentheses, so not next to the x, so it's not part of the exponent, is going to cause a vertical shift. So as k gets bigger, our horizontal asymptote is moving up, our floor of our function, as well as our initial point moved up. So in this case, k is 3, our initial point moved up 3. Also, our horizontal asymptote moved up 3. K could be negative and it will move down. So both the initial point has moved down 3 and the horizontal asymptote. The shape of the curve has stayed the same. Let's look at h. Remember, h causes right and left shifts. Now, h is a positive number here. Now, if you look at the equation, this is going to be x minus 3. So in the equation, h operates opposite. So x minus 3, we've shifted 3 to the right. The h does not affect the floor, so the floor of the function stays, in this case, on the x-axis. If h goes negative, meaning this would be x plus 3, notice we have shifted to the left. So these could go in combinations. We could have, say, x minus 2 plus 3. So this function, if we filled in the letters, would be y equals 2 times 3 raised to the x plus 2 power plus 3. So we have left 2, up 3, as well as our asymptote has moved up. So let's finish up this. By now you should be getting the handle of this. Let's look at exponential decay. Everything is going to operate the same in terms of the h and the k. H moves us right and left, and k moves the asymptote up and down, and the shape of the function stays the same. In these models, let's say we've shifted up 2, right 3. B still does the same thing. As b gets closer and closer to 1, we're flattening out. As b gets smaller, we have a bigger percent decrease. It's getting steeper. And our a value is changing. Well, if it goes negative, it's going to flip it around the horizontal asymptote. And if a is positive, we are moving up. So relative to where the y-intercept would be here, it's still a shift of 3 to the right and 2 up based on our h values. So let's look at now doing graphs on our own. So I'm going to do it in 2 steps. We're going to first start with just the simple exponential model, and then we'll do one with translations. So when we're doing our simple model, we'll want to start out and draw our horizontal asymptote. For the simple model, it's always going to be the x-axis. And we'll plot our first point, which will be the y-intercept, which will be 0, comma a, so our a value. We'll then look at growth and decay. Now that tells us if it's growth, we want to get close to the asymptote on the left side. If it's decay, we get close to the asymptote on the right side of the graph. And then we're going to calculate a second point. If it's growth, we will use the value x equals 1. And if it's decay, we'll use the value x equals negative 1. Now remember, if you pick an x value to find the y value, we just plug it into our function. We'll plot that second point, and then we'll sketch the shape of the curve in our exponential shape. So let's look at a couple examples here. In our first example here, we have a exponential, because this is our b, exponential growth. So a is 5 and b is 2. Now there are no translations. There's nothing added or subtracted to the x and nothing added or subtracted to the end. So we know our horizontal asymptote is the x-axis, so you could sketch a dashed line there. We can plot our initial point, our y-intercept. That's going to be at 0, 5. And since this is growth, we know that we are going to approach the asymptote on the left side and we'll be increasing over here. So we want to pick a value of x. So now we've already picked 0 and we got 5 for here, and now we want to pick 1. So I'm going to be calculating 5 times 2 to the first power, which is 10. So my second point is going to be at 110. And now the best you can, we sketch in. So we're getting close here, and then we're going up with our characteristic bend. Sorry, with my tablet here, it's hard to draw nice smooth curves. All right, let's look at one that's an exponential decay. As you can see, as we get good at these, we can graph them quite quickly. So A is 3, B is 1/2 or 0.5, so that tells us we are decay. And we're going to plot 2 points. Our y-intercept, which is going to be 0A. And let's put our horizontal asymptote on here. Again, since there's no translations, the horizontal asymptote is on the y-axis, the x-axis. Now for for decay, we're going to pick x as -1. So I'm going to be calculating here 3 times 1/2 raised to the -1 power. Now if you remember from when we did exponent properties, a -1 power flips a fraction. So this is the same thing as 3 times 2, which is 6. So if you understand how these reciprocals work with the -1 exponent, you can calculate these in your head without having to pull out a calculator. So we have the point -1/6. And lastly, since this is decay, we're getting close to the asymptote over here. And so now we can sketch in getting close to the asymptote. And then as we get here, we increase rapidly. So that's an example of a basic exponentially decay. You can see they're pretty quick once you get the hang of it. Now we're going to add the translation. So we're going to add possibly an adding or subtracting in the exponent and an add or subtract on the end. So remember, the k value moves our asymptote. So we'll first start out drawing our floor, which will be y equals k. Now our initial point, our y-intercept, where the A is, has been shifted to the right or left by h and up or down relative to the asymptote. So we can use this formula, if you can remember it, to find the initial point. And then again, we're going to, if it's growth, get close on the left. If it's decay, close on the right. And we will pick a second value, which we're going to pick 1 unit to the right if it's growth, and 1 unit to the left if it's decay. And then we'll sketch our curve. So let's look at some examples here. So in our example here, A is 2. So this is our A. This is our B. This is our K. And we have to take the opposite of this number to get our H. So B is 2. So that tells us we're growth. H is the opposite of this here, so it's -1. And K is +2. So remember, we're going to start out by putting our horizontal asymptote, which is going to be at K. So I'm going to draw a horizontal line here at 2. And we will be getting close to the asymptote since it's growth on the left side, so we'll be flattening out over here. And now we're going to pick 2 values for x. We're going to pick h, which is -1, and then so this is h, and then we're going to pick h plus 1. So -1 plus 1 would be 0. And we can just plug in if we want to calculate here. So here for -1, we've got 2 times 2 to the -1 plus 1 plus 2. That's 2 times 2 to the 0 power plus 2. If you remember from the exponent properties, 2 to the 0 power is 1. So we're just going to get 2 times 1 is 2, plus 2 is 4. This will also always just be A plus K if we start with this point. So we're going to put the point -1, 4, -1, 4. And now we're going to add 1 to this number here, so 0. So I've got 2 times 2. Now I'm doing 0 plus 1 in my exponent. So that's going to be 2 times 2 to the first plus 2. So 2 times 2 is 4 plus 2, we get 6. So when we go to the right, we're going up 2. So that's another shortcut here, is we're going to be going up by this number when we move over 1 unit. So now we can sketch in our exponential growth shape, and we're done there. Again, this isn't touching this, but getting closer and closer as we go further left. And now finally, our last example. This one we have A is 5, B is 1/2, so that means we're decay. Our H is opposite of that number, so it's -2, and our K is this number here, so -1. So our horizontal asymptote is at K, so I'm going to draw a horizontal line here at -1. Let me move that line down just a little bit there. Okay. And since it's decay, we're going to be getting close on the right side. And now we're going to pick 2 values just like we did last time, except when it's decay, we're going to pick H and H minus 1. So I'm going to pick -2 and -3, and we're just going to plug those in. So I've got 5 times 1/2. Now when I put -2 in here, I've got -2 plus 2 is 0. Minus 1. Remember, anything to the 0 power is 1, so I've got 5 minus 1, I get 4. Again, this is going to be A plus K if you pick H for our initial point. So here we're at -2 and 4. Now I'm going to go, this time since it's decay, I'm going to go to the left one. So now I'm going to plug in. Now if you go left one, this exponent here, if you start at H, this exponent's always going to be -1 on decay and +1 on growth. Now remember, 1/2 to the -1 is the same as the reciprocal of 1/2. So now we have 10 minus 1, we get 9. So we go to -3 and up to 9. This is up 5 units, left 1. And now we sketch our graph. And that's it. So you can see, if you understand the behavior of exponential growth and decay functions, sketching them is fairly straightforward. So good luck with your graphing.
Are you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you